So, I think our responsibility in Micatu, we take this really serious. I think what we want to do is be able to give the real-time power quality. And, we see that the world's dynamic, weather's changing, right? There's a lot of challenges that we have to take care of. And what we see as data being the new currency, and what do we mean by that? Is that if you can have preemptive understanding of the situation of the grid, of the equipment, it really gives you ability to take these outages and increase your ability to detect them, and so that you don't have one. So as we move forward and as we're bridging this gap between renewables, between fossil fuels, is that we have an opportunity also to have a better understanding and what I call situational awareness. And this is going to be data driven, right? We need good data to make good decisions. And this will tie back to the ADMS, the OMS systems that previously would be reactive, non-reactive, but now we got to be reactive. We can't say, okay, something broke, let's go take care of it. Let's move the grid and migrate it towards where we can predict and we can make actually decisions before it happens. Likewise is that we see Harmonics as the future. And we've had some really, really great partnerships with some of the leaders in renewables, and particularly Amanda, down your part of the woods, is that we see like people like APS, where Harmonics are going to be a big component of their grid going forward.
For people who don't understand the importance of harmonics, I think of it very simply, being the civil engineer that I am, not the mechanical engineer that you guys are, and electrical engineers. But do you remember that movie from like a long time ago, the Tacoma Narrows Bridge, where there was wind shear that hit the bridge and the bridge started going like this? You see that one guy running down the bridge trying to escape before the whole bridge collapses and go.
Yeah.
That's how I think of harmonics. Is this correct? When you're thinking about the resistant, what's happening to a system with the resonancy that's happening, is that correct? Is that why this is so important to the grid?
Yeah, and thank you for such a great example. You really can think about it that way, is that, I think voltage harmonics are really helpful to actually help you identify in current harmonics the problems and the location. So
Okay.
what would generate harmonics is like nonlinear power supplies, highly inductive loads. A lot of the stuff you see outside of factories can really generate those harmonics. And what they do is they have the potential to really put strain on industrial components, industrial equipment.
Okay.
And so that's why power quality is so important, is that when you're actually, and where it's all coming from is a lot of it, if you think about renewable energies, they're DC, right? We have an AC grid. So we got to marry the two. And that conversion from DC to AC can really cause problems. You have an inverter or this actually failing, that can put a lot of bad power quality on your grid. So something that we should be concerned about.
So it's basically trying to protect the equipment on either side, both the utility side and the customer side.
Exactly, and it's important to be that way too. I think that it's a good understanding. You think about the impact to data centers. You think about the impact to how much our life is actually on the internet. Data center power quality is really important. And they monitoring opportunities for that, not only at the substation level, but internally. So we really see this as a dynamic grid of microgrids, and then one wants to even small commercial grids that are connected to the larger utility grid.